Did you know that when you look up at the night sky, you're only seeing a tiny sliver of what's truly out there? On a clear night, far from city lights, you might see a few thousand stars, each a distant sun. But what we see is only a tiny fraction of what's truly out there. Our Milky Way contains hundreds of billions of stars, and it's just one of hundreds of billions of galaxies. The total number of stars in the universe is staggering, more than all the grains of sand on Earth's beaches. Imagine our sun as a single grain of sand, and the universe as a vast, endless shore. Each star could have planets, worlds orbiting in the darkness. For centuries we could only wonder if planets were common. Now telescopes reveal they are. Most stars have families of worlds, giant and small, rocky and gaseous. The universe is not just an ocean of stars, but an ocean of worlds. This leads to a deeper question. Among this multitude, could ours be the only one with life? With so many potential homes, it seems almost inevitable that life has taken root elsewhere. The possibility lingers in every exploration. Are we a lonely miracle, or just one voice in a cosmic chorus we have yet to hear? The search for an answer has captivated humanity for generations. Not every planet is a home for life. Some are gas giants, others are scorched or frozen wastelands. Life as we know it needs a special set of conditions, chief among them liquid water. Scientists call the region where this is possible the habitable zone, or the Goldilocks zone. Not too hot, not too cold. Our telescopes now find planets in these zones around other stars, rocky, Earth-sized, and possibly wet. Billions of such worlds may exist in our galaxy alone. The ingredients for life, carbon, water, energy, are common. If the right conditions are also common, life itself should be too. The universe seems primed for life to flourish, yet when we listen for signs, we hear only silence. The stage is set, but the actors are missing. Why? In 1950, physicist Enrico Fermi asked a simple question over lunch. Where is everybody? If the galaxy is so old and full of stars, why haven't we seen evidence of other civilizations? No alien ships, no grand structures, no messages, nothing. This is the Fermi Paradox, the gap between the expectation that life should be common and the lack of evidence for it. The Milky Way is ancient, 13 billion years old. Our solar system is a newcomer. There's been plenty of time for life to arise and civilizations to spread. Even a million-year head start could allow a civilization to colonize the galaxy. Yet the cosmos remains silent. The paradox persists. Where is everybody? The question echoes through science and philosophy alike. To grasp this mystery, consider the vastness of time. Earth is 4.5 billion years old, but complex life is recent. Humans even more so. On the cosmic calendar, our existence is a blink. Other planets could have had 100 million-year head start. A civilization that old would be unimaginably advanced. Even at slow speeds, they could cross the galaxy in a few million years. Self-replicating probes could explore every star. Yet Earth shows no sign of visitors, no artifacts, no evidence. The silence suggests no one has made the journey. The galaxy is old and vast, with countless opportunities for life to expand. Still, we see nothing. No megastructures, no signals. The ancient stars remain mute. The silence of deep time is profound. One explanation for the silence is the Great Filter, a barrier that's nearly impossible for life to cross. It could be the origin of life itself. Perhaps that spark is vanishingly rare. If so, we may be alone or among the very first. But what if the Great Filter lies ahead? Maybe civilizations destroy themselves before spreading to the stars through war, environmental collapse, or other traps. The silence could be a warning. Most who reach our stage do not survive. The galaxy may be a graveyard of failed civilizations. Are we special enough to break through, or will we join the silent majority? The answer may determine the fate of life in the cosmos. The stakes could not be higher. Not all theories are so bleak. The zoo hypothesis suggests advanced civilizations exist, but choose not to contact us. Perhaps we're in a cosmic wildlife preserve, observed but untouched. They might be waiting for us to mature, or simply following a rule of non-interference. Their technology could be so advanced we'd never detect it. The silence, then, is deliberate, a quarantine, not emptiness. Maybe we're too primitive to interest them, like ants to humans. Our achievements might be trivial to beings millions of years ahead. They could pass by our solar system without a second thought. The silence is not hostility, but indifference or patience. We may not be alone, but we have been left alone on purpose. The zoo's keepers remain hidden. The mystery endures. Another idea is the rare Earth hypothesis, that complex life is exceptionally rare. Earth's conditions may be a cosmic jackpot, a large moon stabilizing our tilt, a magnetic field shielding us, and a protective giant like Jupiter. Our position in the galaxy is safe, far from dangerous radiation. The right number of asteroid impacts shaped evolution. Too many or too few, and we might not be here. All these factors, and perhaps more we don't know, may be needed for intelligence to arise. If any are missing, the journey to complexity could be cut short. The universe may be full of microbes, but thinking beings are rare. We are not just lucky. We are the winners of a cosmic lottery. Our existence may be a near impossible fluke. The silence could be the sound of rarity. We may be more precious than we realize. Our search for life is limited by our own technology and imagination. SETI listens for radio signals, but that's like searching an ocean for a single message in a bottle. We can only scan a tiny fraction of the sky and only certain frequencies. What if advanced civilizations use methods we can't detect? Neutrinos, gravitational waves, or something beyond our understanding. Life itself might take forms we can't imagine. Silicon-based, plasma-based, or something stranger. We search for what we know, but the universe may be far more diverse. The evidence could be there, but invisible to us. The silence may reflect our own limits, not the universe's emptiness. Our search has just begun. The cosmos may be full of wonders we have yet to comprehend. We are only at the start of our journey. So, where does this leave us? The universe is vast, the silence profound, and the answers elusive. The Fermi Paradox is not just a puzzle, it's a mirror for our hopes and fears. If we are alone, life here is unimaginably precious, and we bear a great responsibility to protect it. If we are not alone, the search connects us to a larger cosmic story. The hope of finding others drives our exploration and fuels our curiosity. Whether we are a singular miracle or one of many, the journey to find out is noble. The act of asking, "Where is everybody?" pushes us to be better scientists, explorers, and stewards of our world. The stars are waiting. The silence is waiting, and we, on our small blue world, will keep looking up, listening and wondering. The search itself gives meaning to our place in the cosmos. The journey continues. The universe awaits our next question.